Hello. In this video, I'm going to share a few tips and tricks regarding the blend shape workflow in Houdini. So usually when we are dealing with meshes which are not very dense and we have just a few blend shapes, performance is not an issue. However, when we are dealing with more complex meshes or characters and we have a large number of blend shapes to deal with, the performance can drop significantly. So in this video, I'm going to share a few tips how to optimize the blend shape workflow. So if you look at the scene here right now, I have only the character geometry. So we'll need, of course, a few blend shapes. And I will create a few quick blend shapes so I can better show the whole setup. Usually there are quite a few groups of blend shapes. For instance, one group of blend shapes for the eyelid, one for the eyebrows, lips, and so on. For this example here, I will just create a few shapes for the eyebrows and let's say another one, for instance, for the mouth corner. And that should be enough for this example. So I'm going to create first a few shapes for the eyebrows, and I'm going to just use soft transform node to quickly create a few shapes that I can work with. So I'm going to create one shape for the inner eyebrow, one for the mid, and one for the outer eyebrow. So that should be fine for the inner eyebrow. I'm going to use something similar for the mid and out as well. This one's going to be out, and I'm going so these are three shapes for the eyebrows. And let's create a blend shape node and connect all these shapes here. And this will be blend shapes eyebrows. Update the channels. So now we have three shapes for the eyebrows. And I'm going to do something similar for the mouth corner as well. So I'm going to just select different point here. So this will be left up mouth corner. For this example, this will be just fine. So this will be up and this will be down. And this will be in the out direction. And I'm going to create another one for the in direction. So here we have another blend shape node with all the mouth corner blend shapes in different directions. And then I'm going to create another blend shape node that will be used to merge all those different shapes together. So this will be blend shape face. And this will be the final shape. Of course, these are just an example shapes, and in the real setup, the actual shapes would be very different and much better in terms of quality. But for our example here, this will work just fine. What we want are just a few shapes that can be used for this example setup here. Now, if you're wondering why I'm using here different blend shape nodes here, instead of connecting everything to this main blend shape face node, is that I'm simplifying complex setups here a bit. Usually this whole part, for instance, for the eyebrow here, would be much more complex, and it would include other shapes such as corrective shapes, combo shapes, and so on. So I would usually separate all these parts into different subnetworks and then blend them together. So I'm just using a simplified setup here, so it's easier to focus on the blend shape setup. However, usually there would be a large number of blend shape nodes in a complex setup, and they would be connected to one another, similar as we see here. So smaller parts would be blended into larger parts. So now we have the basic setup here. Now the first thing that we can notice here is that we are only interested in just a small part of the overall mesh, which is the face. However, we are passing the whole geometry through this whole network. So this can be good for the overall performance. So the first thing that we might think is by using the group parameters on the blend shape nodes, which will limit the computation for just those points in this group. So let's do that next. But first, I forgot, I just have to update the channel names from input so we get the correct blend shapes applied and set the value to 1, because we just want those deformation to be passed to the main blend shape face. And maybe one thing that we can do is actually add some keyframes to these blend shapes, so we'll better see what's happening in the viewport. So I'm going to set some keyframes for these 3 shapes. Set some keyframes so there's some animation in the blend shape, and it will be easier to see whatever is happening to the blend shapes. And I'm gonna just set first for the keyframes for the eyebrows. So, and I'm gonna do the same for the mouth corner. Okay, so we have some animation going on here on the blend shapes, so it will be easier to see what's going on. So now let's add the group first. So we're gonna, into this group, we're gonna just add the points that this whole face blend shape will work on. So I'm gonna add points, and I'm gonna just name this group face. Add the eyebrows, and then add this part. So this should cover pretty much all the deformations of the face. And here now, in all these blend shapes, I'm gonna just set the group, points, and face. So now this will help because we're not recalculating the position for all points, but just the face group. However, we are still passing the whole character through the blend shape part of the setup, even if it's not being recalculated at every step. And this will slow down the performance. So here we can see that the whole character is still being passed through. So the whole geometry of the character. So what we would like to achieve is have only the face geometry being passed through this part of the setup. So through the eyebrows and the mouth corner part of the setup. and then have the modified information being passed back to the whole geometry blend shape setup. So for that, we will delete everything but the face geometry before working on the blend shapes. So what I'm going to do here is I'm going to create a blast node that will delete everything with the face. So this will be now base for the blend shapes. Create a null node, and this will be blend shape base. And I'm going to connect all this here. So that would be all these nodes to this node now. Right now, of course, the soft transforms and everything that worked on specific points will not work correctly because the point numbers changed when I use this blast node. So I'm gonna have to reselect these point groups. So this is the reason why this must be done first before actually creating blend shapes. Now here, of course, it's not a problem because we are using just an example, but otherwise preparing this geometry should be done first. So if we decide to use this workflow, it should be done before actually preparing the blend shapes, simply because the points number changed, and this of course is very important in the blend shape setup. So now, if we look at I'm gonna look at this blend shape here, we see it works fine here now, and for the mouth corner, it works fine now as well. Of course, now we have a problem here in the blend shape face because the blend shape face does have a different geometry than each of these blend shape node has. So what we need to do is tell which point here will be mapped here, and this is supported by the blend shape node with point ID attribute. So what we will do is here, I'm going to create an attribute triangle. And I'm going to call this initialize, and this work on points. And all I want to do here is store the point number or the base point number. So this attribute will not change, the same as point numbers will change here in the blast node. So the point numbers will be, this base point number attribute will stay the same when we are deleting this part of the geometry. So what we can do is tell the point ID attribute, instead of using the point number, we are using the base point number, so the one we stored. So now we see that this works fine as well. So this way we can have, if we have very complex characters and we are working on different parts of the character, we can simply use this workflow. We can first store this base point number and here separate the geometry, work on different parts of the geometry in each own blend shape node, and then we're simply merging together to the main whole character through just one blend shape node. And we are using this base point number to tell which point on each of these parts is the point on the main character or the full character. And this will optimize the blend shape performance by quite a lot, especially when we're dealing with dense geometry and we are modifying just a small part of the geometry like the face in this instance. The next step is to optimize the blend shape nodes that we have here. So for blend shapes like for the face here, we're only interested in point positions. So what we can do is limit the interpolation to only position attributes. So if I select all these blend shapes, instead of interpolating all the attributes, I can just set it to P so that we are only interpolating the position attribute, which is what we're interested in this case. Now, the next part are the normals. And in the end, of course, we would like to end up with the correct point normals. And usually there are many blend shape nodes in full character setup. and updating the normal in each of these blend shape in every step of the way will slow down the performance. So what we can do is completely ignore normals throughout this part of the setup and just update them after we are finished with blend shapes. So here in all these blend shape nodes, I will disable interpolate rotation of normals, quaternions, and transformations because we are just not interested in this, and I'm just interested in the position. So the next step is that I update the normals manually. So what we want to do here is add the attribute wrangle. And I'm going to connect the first input to geometry and the second input to blend shape face. And I'm going to name this one update normals. Now I could also use the deformation wrangle, which will automatically deform the normals. But for this example, I will just use the attribute wrangle. So I can set the group to face because nothing else has been modified in the blend shape face. And what I will do is just copy the point position from the blend shape face, but enable the update normals if displaced parameter. And I'm going to create a switch node here so we'll better see what's going on. So I'm going to enable the point normals, just scale them down. So now if we compare, we can see that the normals are properly updated. And this is the difference after updating the normals and before updating the normals. So basically what we're doing, just saying move the point to the position of the blend shape face, and while doing it, just update the normals as well. And this can optimize the performance by quite a lot, especially when dealing with a large number of blend shape nodes, and we save this every step of the way, the calculation of normals, and in the end, just do it once. So in a setup with lots of blend shape nodes, this can have quite an impact on the overall performance of the whole setup. Now in this setup, we have a static blend shape setup. This means that there's no deformation setup on the blend shapes, which is animated, but rather there are static shapes, so the input shapes of the blend shapes are not changing. And we are just dialing their value in the blend shape node. So all these shapes are not animated or being deformed by a deformer or anything like that. We are using the blend shape parameters to animate these shapes, and these inputs are static shapes. So when all the input shapes are static, or in other words, the input shapes are not changing, we can use the cache input deltas so that the attribute differences are cached. Now, we shouldn't enable this on the blend shape face because these blend shapes outputs are changing because they're animated here. However, the inputs of these two blend shapes don't change, so we can cache their input deltas. Now, usually in complex setup, there's not just one deformation node like the soft transforms here, but could be many nodes in the network and many shapes in the overall setup. So for each of these shapes, there will be a lot of nodes to create this shape, for instance. So this usually impacts the scene loading time quite a lot because every deformation has to be recalculated. So if you have like hundreds of shapes, there's a lot of nodes that have to be recalculated every time we load a character. And if you're dealing with static shapes, we can optimize this loading time by stashing or file caching this part. So we can create either a stash node, which will save the shape into the scene file or asset, or we can use the file cache node, which will save it into the external file. For very complex setups or dense geometry, I prefer the file cache node because it doesn't clutter the asset or scene file. But for this example, I'm going to use a stash node. So what we can do here, and I'm going to just create a stash node here. and just use the stash input. Now, whenever the scene file is loaded, it will just load the stash node shape instead of calculating this whole network. Of course, now the network is very simple, but as I mentioned, this network can be quite complex. However, we can further optimize this part. So first, we want to stash only the information we need for the blend shapes. So that is point positions. So what we can do is we can delete everything but points and stash just that information. So for that, we can use the extract all points node. And I'm going to put it here. And then stash the input again. And we can see that this worked just fine. But if we compare this, and I'm going to just create another stash node. So this one will stash everything, the whole geometry, and this one has just the points. And if you look at this, we see that it has the memory of 6 megabytes, and this one has only 117 kilobytes. So the size is much, much smaller. And that means, of course, faster loading times and smaller file sizes. So I'm going to do this for all these shapes here and just use stash input. Now, of course, whenever we would be updating any part here, this stash node would just have to be stashed again. So again, just clicking on stash input, or while working on this shape, I would just disable these two nodes. And then when done with the whole part here, I would just enable them again and just stash input again. So this is what can be done here. And I'm going to just do it for all these shapes here. I'm going to just place these things a little nicer here in the viewport. Okay. And now if you look at the output, we see that everything works just fine. And we are passing less and less information for all these nodes, which of course can only make this whole thing faster. We can further optimize this part by deleting any attribute that we don't need to pass through this whole network. And also, if you have a lot of attributes, we don't need to stash them into these nodes. So we can create less data in the stash nodes by just deleting the attributes that we don't need. So we want to just keep the position, and in this case, base enum attribute. For the vertex, we can delete everything but the UVs, and we can delete all the primitive and detail attributes. So now, when we are stashing all these inputs, we can see that we are stashing much less data than if we would be stashing the whole character. So this way we are just stashing what is necessary for the blend shapes to work. And whenever we wish to update or modify the shape, we can just disable the stash node, make any modifications, and afterwards restash the shape again. So those would be my tips for optimizing the blend shape workflow and what I usually use when I have a full character with lots of blend shapes. Every step of this usually helps a little bit, so the overall performance is usually much better than if I would be directly connecting all the shapes the character has into a single blend shape node. And that is all for this video. and I hope it will help you in your own setups, and see you next time.